why you would weigh less on the moon, but not on Earth? Or why a tiny pebble feels much lighter than a big rock in your hands? These questions can be answered by understanding two important concepts: mass and weight. Although people often use the words interchangeably, they're not the same thing. Mass is about how much matter is in something, while weight is about how gravity pulls on that matter. Today, we'll break it all down and explore what makes these two ideas so different. We'll also discover how gravity plays a big role in weight and why astronauts feel weightless in space, but they still have mass. By the end of our lesson, you'll be able to explain why your weight might change if you visit the moon, but your mass never will. Let's dive into the fascinating world of science. So, what exactly is mass? Mass is the amount of matter that makes up an object. It doesn't change, no matter where you are in the universe. So, imagine holding a block of clay. Whether you're on the Earth, or on the moon, or even floating in space, the clay will still contain the same number of atoms and molecules. It has the same mass. Mass is a fundamental property of matter, and it's measured in units like grams or kilograms. Mass is measured using a balance scale, which compares an object's matter to its known weight. The more matter an object has, the greater its mass. The concept of mass helps us to understand the stuff that objects are made of. For example, even though a balloon is really large, its mass is actually really small because it contains mostly air. On the other hand, a small rock has a lot more mass because it's denser and it contains more tightly packed matter. For our first activity, we're going to be determining mass. We'll need a balance scale and some objects of different sizes. We'll also need paper and a pen to record our mass. So to begin, we're going to pick an object and put it on our balance scale. Okay, we're going to start by measuring our ping pong ball. So I'm going to go ahead and set it on the balance, and then I'm going to compare its mass with one of my little weights over here. So I think I'm going to start kind of small because I don't think it's going to weigh 50 grams. That's way too much. So let's start with something like 5 grams. 5 grams is still too much. Let's go ahead and try even smaller. Let's try just 1 gram. And it balances really well. So we know that our ping pong ball has a mass of 1 gram. Now I'm going to try another object. I thought it would be fun to do some hot chocolate. All right, I'm going to go ahead and see if the 50 grams, no, the 50 grams has a lot more mass than our hot chocolate. Let's go ahead and try 20. Well, it's more than 20 grams. Let's add another. All right, so we have 20 plus 10 plus 2 5s and a 2. That makes 42 grams. All right, next I got a koosh ball. I feel like this weighs less than our hot chocolate. So let's go ahead and start with the 20. Let me see what happens if I add 1 more gram. That looks perfect to me. So our koosh ball, 21 grams. Next, let's look at a rubber ball. Let's go for the 20. All right, so it's more than 20. And that looks pretty even. So we know that the mass of our rubber ball is 20 plus 10 plus 5 plus 2. So that makes it 37 grams. All right, now we're going to check the mass of a rubber duck. So let's go ahead and start with a 5. So our duck is 5 grams. And last but not least, I brought a cowbell. So let's go ahead and start with our 50. I was right, it's definitely more than 50 grams. Let's see what happens if I add the 20. It's 50 plus 10 plus 5 plus 2 plus 1. So that makes it 68. So as you can see, our object with the most mass was the bell, and our object with the least mass was the ping pong ball. So there's a lot more matter making up our metal bell than our ping pong ball that's mostly air. So we just learned about mass, so then what is weight? Well, weight, unlike mass, depends on the force of gravity. Weight is how strongly gravity pulls on an object. On Earth, gravity pulls objects downward with a specific force, giving them their weight. However, if you were on the moon where gravity is much weaker, you would weigh less even though your mass stays the same. Weight is measured in units like newtons or pounds. The formula for weight is weight equals mass times gravity. So let's think of an example. Say a heavy backpack. On Earth, the backpack feels heavy because gravity is really strong here. Now, if you took the same backpack to the moon, it would feel a lot lighter because the moon's gravity is only about 1/6 as strong as Earth's. So weight changes depending on the strength of gravity in different places. For our next activity, we're going to be determining weight. So for this activity, you'll need a spring scale and you'll need more objects. I'm also going to need a paper and a pen. So I think I'm going to go ahead and start with this block of wood. So this measures 800 grams. So I'm going to go ahead and write down that my block of wood is 800 grams. Next, I'm going to go ahead and weigh my hairdryer. My hairdryer says 0.5 kilograms, so that makes it 500 grams. Now, I think it would be hard to weigh these using this spring, so I'm going to go ahead and use some baggies to help me weigh it. So first, I've got a can of beans. Let's see how much our can of beans weighs. My can of beans says 0.6 kilograms, so that's 600 grams. And last but not least, I have some caramel coffee creamer. I got 1.2 kilograms. So that means it's 1,200 grams. So just like before, I'm going to go ahead and compare which is the heaviest and which is the lightest object. So my hairdryer was 500 grams, while my coffee creamer was 1,200 grams, or 1,200 grams. So the weight of my coffee creamer was much more than the weight of my hairdryer. Our weight would vary if we were somewhere else, like on the moon. So while this has the same mass wherever I take it, its weight is only going to be 1,200 grams right here on Earth. So by now you might be asking yourself, well, how does gravity affect weight, but it doesn't affect mass? Well, gravity is an invisible force that pulls objects towards the center of our planet, or other massive bodies. On Earth, gravity is what makes things fall to the ground and gives them weight. The strength of gravity depends on the size and mass of the planet or the object. Let me give you an example. Earth's gravity is stronger than the moon's gravity because Earth is larger and it has more mass. That's why astronauts feel lighter on the moon. They weigh less because the moon's gravity is weaker. Mass, however, is not affected by gravity. Whether you're on the Earth or the moon or out in space, the amount of matter in an object stays the same. This is why scientists use mass to measure how much stuff is in an object, regardless of its location. So weight changes because gravity changes, but mass is a constant property of matter. So for our next activity, we're going to go ahead and use an orbiter, and we're also going to need a ball. So this shows us the sun, the Earth, and the moon. So as you can see, the moon is about 1/4 or 1/4 of the size of the Earth in width. So another way to put it is that Earth is about 4 times wider than the moon. So as we were just discussing, the larger our object in space, the more gravity it has. Now, here's our ball. If we drop it, gravity is pulling it to the ground. So our ball, which we weighed earlier, would weigh less on the moon than what it weighs here, but it would have the exact same amount of mass. So exactly how much different is it between the Earth and the moon? Well, a 1-pound object on Earth only weighs 0.17 pounds on the moon. So we'll remember this by saying that the gravity of the moon is approximately 1/6 of Earth's gravity. So if you divide a 1-pound weight by 6, that gives you 0.17. Now, here's another way to look at it. I weigh about 125 pounds on Earth, but on the moon, I only weigh 20 pounds. It's the same weight as a medium-sized dog like a beagle. So you may be thinking, how do we measure mass and weight? Since mass and weight are different properties, they're measured using different tools. So a balance scale, like we used earlier, measures mass by comparing an object to a known mass. So right here, we have our weights, which are a known mass. So this one we already knew was 50 grams. Whenever we put another object on it, we were comparing it. Now, this works the exact same way on Earth, the moon, or even in space, just as long as there's not air resistance. On the other hand, a spring scale measures weight by measuring the force of gravity that's acting on an object. So our spring stretches more for heavier objects. Now, this is why we use balance scales in science labs to measure mass, because it doesn't depend on gravity. Meanwhile, a spring scale is used to measure weight because it directly shows the effect of gravity. So understanding how to use these tools helps us to measure and differentiate between mass and weight accurately. Today, we learned that mass and weight are not the same thing. Mass is the amount of matter in an object, and it never changes, no matter where you are. Weight, on the other hand, is the pull of gravity on an object, and it changes depending on the strength of gravity. This is why you would weigh less on the moon, but you'd still have the same mass. Understanding these concepts help us make sense of how gravity works and how scientists measure objects in space and on Earth. Remember, next time someone talks about weight, you can share the cool fact that their mass is the same, no matter where they are.